Hello, and welcome to the Section 1.1 video lecture. I'm Dr. Scott Spaniel. I'm your instructor for this course, and this is our first video lecture to start off the class. So, to follow along as I go through this section, one thing you can do is download or print off the note sheets, which, depending on your course format, is found in one of two places, either on Blackboard in this week's folder or on my math lab at the handouts, the video lecture, link. So what you can go ahead and do now is take out those note sheets or bring them up on your screen if you want to follow along. And they should look something like this. And so in this first section, we're just going to be introducing you to the idea of how the study of statistics is going to work. So we're going to be introducing a lot of new terms that you may have heard before, but might also be brand new. So, statistics is the science of collecting, organizing, and summarizing and analyzing information to draw conclusions or answer questions. In addition, statistics is about providing a measure of confidence to any conclusions. So basically what we're going to build up to in this class is the idea of making conclusions based on numerical data. That's really where we're going with this. And being able to state how confident we are in our result. Data is a fact or proposition you use to draw a conclusion or make a decision. The entire group of individuals to be studied is called the population. An individual is a person or object that is a member of the population being studied. A sample is a subset of the population. So the word population in our everyday context is usually used to talk about the number of people in a group. And that's part of it. But it's not just the number of people in that group, it is the group. So the population of the United States isn't the number of people in the United States, it's those people themselves. And so we can talk about populations in big groups like that, or we can talk about populations as in the people in this class are all a population. And then if we take a smaller group of that bigger group, that's what we call a sample. So this class is a subset of all of students in Morton College. So that would be a sample out of the population of Morton College students. So depending on whether or not you're a sample or population depends on context. A statistic is a numerical summary of a sample. Descriptive statistics consist of organizing and summarizing data. Descriptive statistic describe data through graphs, charts, and numerical summaries. Inferential statistics uses methods that take a result from a sample and extend it to the population and measure the reliability of the result. In this course, we're going to talk about both of these. We're going to start off talking about descriptive statistics. And then what we're going to do after that is we're going to talk about probability. And once we've talked about probability, we can use probability to do inferential statistics. So that's kind of how the course is going to be laid out. A parameter is the same thing as a statistic except for the entire population. So the biggest goal of statistics is to use a statistic to estimate a parameter, to use sample data to estimate population data. So the first question we want to look at is this difference between statistic and parameter. So what we're going to do now is we're going to do a couple problems together, and then I'm going to have you pause the video and try a few of these on your own, and then we'll go through the answers. So the question is the underlined numerical summary, numerical value, a parameter or a statistic? So does it refer to a population or to a sample? So following the 2006 national midterm elections, 18% of governors of the 50 United States were female. Okay. So one question you might want to ask yourself here is, well, what's the population we're talking about? Well, in this case, what we're talking about, the population is the governors of the 50 United States. So that's our population. So does this number refer to a ratio for the entire population or just for a sample of that? Well, in this case, it refers to the entire population because they're saying that 18% of the entire population is female. So this would be a parameter. The difference here would be if we were to say take a sample of 20 governors and say 18% of those were female, that would be a statistic because then we're looking at a sample. A second example here, in a national survey of high school students, 25% of respondents reported that someone had offered, sold, or given them a legal drug on school property. So, in this case, the population is all high school students. So the question is, did these, in this survey, did they ask all high school students? No, they would have asked a sample of those. So this would be a statistic. Okay, so this 25% is a statistic. Okay, so at this point, pause the video momentarily and try these other three. Okay, so now that you've had a chance to try these, let's go through the answers. So the average score for a class of 28 students taking a calculus exam was 72%. So in this case, the class of 22 students is the population. This 72% refers to all of them. Therefore, this is a parameter, or uses all of their scores to calculate that 72%. Only 12 men have walked on the moon. The average age of these men at the time of their moonwalks was 39 years, 11 months, and 58 days. In this case, the population is the 12 men to have walked on the moon. So this age refers to all 12 of them. It's the average of all of them, so this is a parameter. And then the last one, telephone interviews of 1,502 adults 18 years of age or older conducted nationwide February 1st through the 13th, 2007 found that only 69% could identify the current vice president. So the population here would be all adults 18 years of age or older. They didn't ask all of them. They only asked 1,500 of them. So therefore, this is a statistic. Okay, so that's some examples of the difference between a parameter and a statistic. Now what we want to do is we want to drop further into this idea of the difference between population and sample and being able to recognize the population and the sample in a paper or a study. So a research objective is presented. For each research objective, identify the population and sample in the study. Okay, so we're just going to go through this together. I'm going to underline the populations in blue and the samples were possible in red. If it's possible to underline both of them. Some of them I might write out, but I'm going to do the first two together again. We'll pause it and you can try the other ones. So a quality control manager randomly selects 50 bottles of Coca-Cola that were filled on October 15th to assess the calibration of the filling machine. So in this case, the sample is pretty straightforward here. It's the 50 bottles of Coca-Cola that he randomly selected. So that would be our sample. So then the question is, well, what's the population? Well, the population is all Coca-Cola bottles filled on October 15th. Okay, so he's using a smaller set of data, in this case, some of the Coca-Cola bottles, to see if the filling machine is working correctly. It would be impracticable to look at all of them because then you have to open them, and if you open them, then you can't sell them. So that's why they take a sample to try and figure out if the population is working correctly. Second one here. Every year, the U.S. Census Bureau releases the current population report based on a survey of 50,000 households. The goal of this report is to learn demographic characteristics of all households within the United States, such as income. So one key takeaway here is usually the word all is a giveaway that you might be talking about the population. In this case, it's all households within the United States. So that's our population. And then the sample are the ones they talk to. So that would be the 50,000 households that they actually contacted. Okay, so go ahead and take a moment, pause the video, and try these other three. Okay, so now that you've tried these, let's go through them together. So a large community college has noticed that an increasing number of full-time students are working while attending school. The administration randomly selects 128 students and asks this question: how many hours do you work per week? So in this case, the population would be all the full-time students at this large community college, and the sample would be the 128 students they actually asked. The next one, the Gallup organization contacts 1,028 teenagers who are 13 years of age and live in the United States, and asks whether or not they had prescribed medications for any mental disorders such as depression or anxiety. So in this case, the population would be all 13 to 17-year-olds in the U.S., and the sample would be the 1,028 teenagers who are age 13 to 17 and live in the United States. And the last one here, a farmer wanted to learn about the weight of his soybean crop. He randomly selects 100 plants and weighed the soybeans on each plant. So in this case, the population would be all soybeans in the crop. And the sample would be the 100 plants that he randomly selected. Okay, so that's the difference between population and sample and how to recognize them in a study. Once again, the word all is a really good giveaway that you're probably talking about a population. Now what we want to talk about is a little bit more about the process of statistics. So, when we want to talk about the process of statistics, there's a few different steps we want to take. So, step one is to identify the research objective. A researcher must determine the questions he or she wants answered. The questions must be detailed so that it identifies the population that has been studied. So you wouldn't just want to say something like, I want to know what percentage of people like Chicago-style deep dish pizza. You have to be specific and say the percentage of what people. So you could say something like, what percentage of all adults in the city of Chicago like Chicago-style deep dish pizza? So that would be an example of a fairly good research question. Number two, collect data. So collect the data needed to answer the question or questions posed. Gaining access to an entire population is often difficult and expensive. When conducting research, we typically look at a sample. The collection of data step is vital to the statistical process because if the data are not collected correctly, the conclusions drawn are meaningless. Do not overlook the importance of appropriate data collection process. And we'll talk more about that in a later section in this chapter. Step number three, describe the data. And this is what we'll be doing in chapters 2, 3, and 4, although we're going to do chapter 4 at the end of the course. So obtaining descriptive statistics allows the researcher to obtain an overview of the data and can provide insight as to the type of statistical methods the research should use. And then the last step is perform inference. And this is what we'll talk about at the end of the course. So apply the appropriate techniques to extend the results obtained from the sample to the population and report a level of reliability of the results. So these 4 steps are what we're going to basically talk about throughout the semester. Slowly but surely, we'll do all 4 of these. Now, that we talked about what we're going to try and do with statistics, what we want to look at a little bit more is what some more of the terms that go along with this. And the next one of these is variable. So variables are the characteristics of the individuals within the population. Qualitative or categorical variables allow for classification of individuals based on some attribute or characteristic. Quantitative variables provide numerical measure of individuals. Arithmetic operations such as addition and subtraction can be performed on the values of the quantitative variable and will provide meaningful results. So there are a couple of key words here for each of these. For qualitative, the key word is classify, classification. Does the value classify you? In the quantitative one, the key word here is numerical measures. Okay, so quantitative variables have to be numbers, but not all numbers are quantitative variables, because in order for a quantitative number to be quantitative, it has to measure it and not just classify it. So the trickiest of these are numbers that are qualitative variables, numbers that don't measure things, instead they classify. And we'll look at a couple examples here to let you see what we're talking about. So nation of origin. So let's go through a few examples together and then I'll have you try a few. So nation of origin. Nation of origin, like the United States, Mexico, Germany, France, China, these are not numbers, so it must be a qualitative variable. Okay, that classifies you, right, by what nation you came from. Number of unpopped kernels in a bag of ACT microwave popcorn. So first of all, it's a number, so it might be quantitative, and then the question is, does it measure something? And in this case, it does measure something. It measures how many popcorn kernels didn't pop. So this would be quantitative. Okay. Next one, number on a football player's jersey. So it's a number, so it might be quantitative, but the question is, does that measure something or does it classify you? And in this case, what it does is it classifies, because what it does is it tells you who that player is. And in a lot of, depending on the level of football, it might actually tell you what position the player plays. So this would be a qualitative. Okay, so at this point, go ahead and pause the video for a moment and try these other 4. Okay, so the first one, number of siblings. So that's counting something, so we're measuring something, so that's going to be quantitative. Phone number. It's a number, so you might think quantitative, but this is actually qualitative, because it does not measure something about you, it classifies you. It's actually a numerical label of you, right? Similar to Social Security number, student ID, things like that. Grams of carbohydrates in a donut. Once again, we're measuring something, so that's quantitative. And then the last one, student ID, I kind of just mentioned. That's labeling you, so that's classifying you, so that's qualitative. Okay, so those are the 2 big types of variables. Then inside of quantitative, there are 2 subgroups of types of variables. So quantitative variables can be one of 2 types. They can be discrete or they can be continuous. So discrete variables, quantitative variables, either have a finite number of possible values, or they are countable. Okay, so that's the important word there. You count them. So we count discrete variables. Continuous variables are quantitative variables that have an infinite number of possible results. So that's an important word here. Another important word that goes with this is the idea of something you measure. So if you're counting something, then it's going to be discrete. If you're measuring something, it's going to be continuous. So runs scored in a season by Albert Pujols. So that's something we would count up. So that would be discrete. Volume of water lost each day through a leaky faucet. So you measure volume, right? You don't count volume, so that's going to be continuous. Length in minutes of a country song. Now this is an interesting one because you can count time, right? 1 minute, 2 minutes, 3 minutes, and so on. But we actually measure the length of time. So time in general is going to be continuous. Okay. So that's the idea. So at this point, go and pause the video for a moment and try these other 4. Okay. Now you've had a chance to try those. Let's go through them together. So the number of sequoia trees in a randomly selected acre of Yosemite National Park. The word number means to count, so that's going to be discrete. Right? Anytime we have the word number, either implied or written out, that's most likely going to be discrete. Internet connection speed in kilobytes per second. That's continuous because that's something we're measuring. If you're given a unit like kilobytes per second, that's a pretty good thing that it's going to be continuous. Not always, but most of the time when you're given a scientific unit. Air pressure in pounds per square inch is continuous because we measure that. We've got a scientific unit here. And points scored in NCAA basketball is something you count. So that's discrete. Okay. So that's the idea between those. So we basically end up with 2 big types of variables, qualitative versus quantitative. And then inside of quantitative, we have 2 subgroups, discrete or continuous. Now, what we're going to do now is talk about one of the trickiest things in this first chapter, which is level of measurement. Okay, so there are 4 levels of measurement, and they're like steps on a rung. It is kind of the way you can think about them. That in order to get to the higher levels of measurement, you have to pass through the lower ones. So a variable is at the nominal level of measurement if the values of the variable name, label, or categorize. In addition, the naming scheme does not allow for the values of the variable to be arranged in a ranked or specific order. The second one, which means is ordinal, which means to order, the ordinal level of measurement. If it has the properties of the nominal level of measurement and the naming scheme allows for the values of the variable to be arranged in a ranked or specific order, specifically the word ranked. A variable is at the interval level of measurement if it has the properties of the ordinal level of measurement and the difference in the values of the variable have meaning. So that's the key. The difference in the values of the variable have meaning. A value of 0 in the interval level of measurement does not mean the absence of the quantity. And we'll look at examples here to see what that means. Arithmetic operations such as addition and subtraction can be performed on the values of the variable. And the last one is the ratio level of measurement. If it has the properties of the interval level of measurement and the ratios of the values of the variable have meaning. A value of 0 at the ratio level of measurement means the absence of the quality. Okay, and we'll look at an example here to see what that means in a second. So basically what these levels of measurement look like is 4 steps on of stairs. So you start at the nominal level and then you go up. So then to the ordinal, to the interval, and then finally to ratio. So in order to get to ratio, you have to go through ordinal and interval. And every variable will start at the nominal level at the very least. So the question is, do you progress to the next step? So let's look at some examples here. So volume of water used by a household in a day. So first thing is, if we had some values of that, you could even try to write out what some of these values might look like, right? How much water could you use in a day? Well, you could use, 5 liters, 15.2 liters. You could even use 0 liters of water, right? So the question is, can I put those in an order? Yes, right? I could order them. It would go in a ranked order. It would go 0, 5, 15.2, right? I could put those in order. Is there a difference between those? And if so, does that difference have meaning? Well, in this case, yes, it does have meaning, right? If I take the difference between 15.2 and 5 between these two houses, that difference would be 10.2 liters. And that would mean that this house used 10.2 more liters than the other house. So we're at the interval level now. And the last question is, do we make it all the way to ratio? And to make it to ratio, the value of 0 would have to mean the absence of the quality. So in this case, 0 liters means that you did not use any water. So that means we didn't use any water, so this would be ratio. Okay, so the first one is the ratio level. Nation of origin. Okay, so nation of origin could be USA, Mexico, Germany, okay, and so on. Can I order those in a way that's a ranking them? No, right? There's no ranking of countries without being more specific about the variable and having a data value to go with this. So that means we did not make it to ordinal. So this would only be at the nominal level of measurement. Okay. The next one, year of birth of college students. So nowadays, that's up into the 2000s. You guys were all, a lot of you were born very young, so that could be something like 2002, 2000, 1998, 1984. Okay? So can those be put in a ranked order? Can those be put in an order? Yes, they can. In fact, they kind of already have been, right? They're in descending order right now. So that means we've made the ordinal level. Is there a calculable difference between these that means something? Yeah, if I find the difference between 2002 and 1998, that's 4 years. That means that this student is 4 years younger than this student. So that has meaning. So that gets us to the ordinal level. Now the question is, what does 0 mean in this context? Well, in this context, the value 0 is a year. It was 2020 years ago. Does that mean that person wasn't ever born? No. So that means that this is only the interval level. Also notice that in this context, 0 doesn't really make any sense. It's possible that a student was born in 0, but they wouldn't be around by a lot now. So if 0 doesn't really make sense in this context, that means you're not at the ratio level. Whereas it's very possible that a house didn't use any water in a day, specifically if no one was in that house, right? They probably don't use any water. And then the last example we'll do together is movie rankings of 1 star through 5 stars. Okay, so we could have a 1-star movie. We could have a 3-star movie, right? We could have a 2-star movie. So can I put those movies in order based on this variable? Yes, right? I could rank them from least stars to most stars. So that gets us to ordinal. Does the difference in number of stars have a concrete meaning? So if I took a 3-star minus 1 star, that would be a difference of 2 stars. Does that mean something concrete? And the answer to that is no. The ranking means something. It means that it's considered a better movie, but the difference of 2 stars doesn't necessarily mean anything. The difference between a 1-star and a 3-star movie does not mean the same thing necessarily as between a 3-star and a 5-star. So that's why we're only able to be at the ordinal, because the differences don't really have meaning. Okay, so at this point, pause the video and try these other 4. Okay, so now you've had a chance to try these 4. Let's go and go through them together. So eye color, right? So eyes could be blue, they could be brown, could be black, right? And there's other options. Is there any way to rank eye color? No, right? Not that we would all agree on. So that means this is only at the nominal level. We can't go any higher because we didn't make it up that first step. Assessed value of a home. Okay, so that'd be like $150,000, $300,000, and so on. Could you put those in order? Could you rank those? Yes. Higher priced houses go above lower priced houses. So that's ordinal. Does the difference between houses have a concrete meaning? 300,000 minus 150,000 is 150,000. That means this house is $150,000 more expensive than this house. So that has a meaning. So now we're interval. And now we're talking about the value 0. Well, a house assessed at $0 means that house has no value. So that has meaning. So that means this is at the ratio level. Time of the day and military time. So remember, military time is really just from 0 to 2400. So times in military time, right, could be something like 0, 600, 1150, okay, 2330, okay. Those are all times in military time. Can we put those in order? Yeah, from earliest to latest. Is the difference mean something? Yeah, if you subtract the difference in times, that's how far apart they are. What does 0, 100 hours mean? Does it mean that the time doesn't exist? No. So that's going to be interval. Now, one thing you may notice about the two interval examples on this page is they both had to do with measurements of time where we were not measuring from a 0 point into the future, right? We are using points in time. And those are good examples of when we end up at the interval level and not ratio. And then the last one is highest degree conferred, high school, bachelor's, and so on. This one does make it to ordinal because we can put them in order by number of years in school to get that degree. But it does not make it to interval because we can't subtract anything. So this would just be ordinal. Okay, so I think we'll skip over these last two pages. These are just more examples of some of the stuff we've already talked about today. And I'll let you practice that in the homework because we're already at a 30-minute video. So thanks for watching the video today. Make sure you're doing your homework. If you have any questions about the course, feel free to contact me via email or remind. And have a good day, and I'll see you at the next video lecture.